Okay, welcome to Unit 4, Lesson 1. We're doing homework help for cafeteria actions and reactions. So let's get started with question 1. Graph the following equations on the coordinate grid. Determine if the given point is a solution to the equation. All right, so we've got our equation here, so we've got to graph that first. Let's do this one. We'll do this first one in green, that'll work. So y equals 5x minus 2. All right, so an easy point to plug in is always going to be a 0. So let's start by plugging in 0 for x. So if we do plug in 0 for x, we would say that, oh, well, y is going to equal 5 times 0 and then minus 2. And 5 times 0 is just 0. So we would get minus 2. That's also just our x-intercept, or sorry, our y-intercept in the equation up there. So our y-intercept is going to be negative 2. So we're going to zoom in on negative 2 just a little bit here and plot that point. So negative 2 would be right about here. All right, so that's our first point. And now let's go back up so we can see the equation again. All right, 5x minus 2. Now 5x, right, if we know that minus 2 is our intercept, 5x is actually our slope. So for instance, if we put in a 1, right, we'd have y equals 5. And if we set x equal to 1 and then minus 2, right, we would say that, oh, okay, well, this is just going to be 5 minus 2, which is equal to 3. So we could plug in, if we put in a 1, we should get out 3. So that should be the point right here. And then we will notice that, okay, well, it's a straight line. It's a, oh, the lights went out on me. Come on, turn back on, please. Excellent. All right. So we have, where was it? So we get, we know that this is a linear equation, sorry. So we have this first point is our y-intercept, and our second point is another point on there. And we know that it's over 1 and up 5. So we can also just follow that pattern. So over 1, up 5. We'll go over, right, so over 1, up 5. Right, that's good. We can go over 1, up 5 again. Right, so 1, 2, 3, 4, and 5. All right, that is 5. Perfect. So we'll put another point up there. And yeah, that should be enough to get sort of a straight line going. We only need 2 points, but we could do more than that. So here we go. We will start drawing here. And it looks like I went over too far at the bottom. I did. I went over 1 too far. There we go. Oh. Here we go. Let's try that trace again. I went over 1 too far. There we go. And that is going to be our drawing. Right, so we wanted to graph the equation, so we've done that. Right, graph the following equations. All right, so we did that. It is graphed. And now the point 1, comma 3, is that a point on the graph? It is. It's actually right here, right? On this one, right? This is the point 1, comma 3, because when we plug in 1 for x, we get 3 for y. So yes, 1, 3 is on the graph. So let's move on to the next one. Let's go to number 2. This one we'll do a little bit faster, a little bit less explaining, and we'll just examine, we'll say that, okay, y equals negative 1/2 x plus 8. So we're going to say that negative 1/2, this is the slope, and 8, this is the y-intercept. I should write y-intercept. All right, so we have the slope, we have the y-intercept, so that's actually all we need in order to graph. So the slope and the y-intercept, all right, so first the y-intercept, if we plug in 0 for x, that means we should be at 8. And it wants me to make a new note, we're not gonna do that. Then negative 1/2 means if we go over 1, we'll go down 1/2. So if we go over 1, down 1/2, we should be here. And then if we go over 2, that'll get us down 1, right? So over 2 down 1 is the same, but over 1 down 1/2 is there, and so on, right? And we can keep adding these dots. And we should be there, and we can go the other way, right? If we go to the left one or negative 1, we can go up 1/2. right? So we just continue this pattern. There we go. All right, and now we'll trace. Yeah, that was okay. It wasn't perfect. Well, we missed by a little bit. So let's do it again. We'll do one more. We'll see if we can trace it a little bit better. Oh, here we go. All right, it moved on me right at the end. I know you all saw that. All right, one more time. Here we go. There we go. That is our trace line. That's actually pretty good. So I'm happy with that. And now the question we have to ask ourselves is the point 0, 7 on this line. Well, we know that our intercept, right? We know that the intercept is going to be 0, 8. So if 0, 8 is on the line, right? 0, 7, right, would be this point right here, right? And is that on the line? No, it is not. So no, the point 0, 7 is not on the line. All right, let's zoom out and go over to our next one. We are skipping number 3 and right to number 4. All right, so for number 4, we have y equals x plus 2. Now, if there's nothing here in front of the x, that actually means that the slope, right, it's sort of like right here, that is the slope. Oh, I shouldn't put that, makes it look like a 0. It's not a 0, actually. It's like an invisible 1. So if there's not a number there, it just means it's a 1. So the slope is 1. The slope is 1. And then we have the y-intercept, which is 2. The y-intercept, which is 2. So we can go right to 0, 2. That's going to be one of the points. That's right here. And then we have to go, if we go over 1 to the right, like if we go right 1, we have to go up 1. So right 1, up 1 gives us that point. Then we can do it again and again and again. Right? And here are going to be the points on our line. And same thing, we could go left 1, down 1 as well. Right? So those are all our points. And now we give a quick line through these. All right. So we have graphed the equation. And now is the point 1, 3 on the line? Well, let's go find the point 1, 3. This would be 1. And this would be 3. So, yep, that is the point 1, 3. So that is on our line. So yes, it is. Another way to find that would be to say, oh, if we have y equals, well, actually, if we're wondering about the point 1, 3, we could just plug in 1 for x and 3 for y and see if it's true. So we could say that 3 equals 1 plus 2. Now, if that is true, right, if this is true, then the answer is yes, that point 1, 3 will be on the line. But if this is not true, then it won't be. And since 3 is equal to 1 plus 2, then yes, we know the point will be on the line. So there's sort of an algebraic way on the right shown, or there's a visual way on the left. Both ways to confirm that yes, the point 1, 3 is on the line. Let's move on to the next question. We are not doing 5 or 6, but we are doing 7. Here we go. For each of the equations provided below, identify the first operation performed on the variable and also identify the last operation performed on the variable. Then determine the first step that would take place when solving and the last step that would take place when solving. Okay, if needed, we will solve and check our solution. So we'll do that on the first one. We will solve and check the solution on the first one. So number 7, I've actually copied up the equation up here just so we have that. All right, so the first operation performed on x. All right, so we know our order of operations is going to be PEMDAS. We've talked about this a little bit, but it's good that we are refreshing it again, right? So first operation is always parentheses. So we look in the parentheses and we see x minus 8. So the first operation to x is minus 8. That's what we're going to do first. The last operation to x. All right, so the last operation, we would do the parentheses and then the multiplication, and then we would add 7. All right, so the last operation is plus 7. The first step, if we are solving, what are we going to do is actually subtract the 7 from both sides. And the last step for solving is we're going to add 8. Now, you might notice that the -8 and the +8 are opposites. That's important. And the +7, -7 are opposites. That is also important. All right. So you'll notice that these are like the diagonals on this grid are opposite each other, but they have the same number associated. So let's check by solving. So we have, we'll copy this over in black. We have 3x, 3, and then parentheses, x minus 8 plus 7 equals 28. All right, so that's what we have for our equation. And let's solve for x now. Let's do that. So we will solve for x. Let's first subtract the 7. We said we were going to subtract 7 first. So subtract 7 from both sides. That's going to give us 3x minus 8 equals 21. Then we are going to divide both sides by 3. Right, divide by 3, so we get just x minus 8 left over here equals 21 divided by 3 is 7. And then our last step for solving we said was plus 8. All right, that checks out. It is plus 8 to both sides. And then we end up with x equals, and what is 7 plus 8? That's going to be 15. All right, so x equals 15. All right, so this would be our solution to this question. Then the question is, if we want to go back and check this, that's when we're going to see the operations to x. That's where we're going to check the operations to x. So let's shift over real quick. We'll just use this empty space here. And let's rewrite our first equation. We'll do this in a different color. How about that? We will do this in... we used purple a bunch. We'll do purple again. I like the contrast of the purple, the black, and the green. So here we go. We're going to plug this in. We're going to rewrite our equation, but we're going to plug in 15 for x. 15 minus 8 plus 7 equals 28. 28. And we went a little bit off the page, but that is okay. We will be just fine with that. Oh, that 8 is real messy, though. I'm not sure I like that. Let's try that again. Here we go. 20. Oh. The fire alarms went off real quick. They are testing those in the building, but that's okay. We will be totally fine. It is just a test. All right, so if we were in class, though, we would be evacuating because when fire alarms go out, you have to evacuate. Unless you're told there's going to be a test. So it's a test today. Or they're just making sure they still work. All right, so anywho, we're now looking at what order we perform, right? Remembering that this 15 right here, right, that is actually our x. So what's the first thing we would do to make sure that this is a factual statement? Well, the first thing we would do is subtract 8, right? Because it's in the parentheses. So rewriting this, we have to do the parentheses first. So we have 3 times, what is 15 minus 8? 3 times 15 minus 8. Well, 15 minus 8 is 7. So it would be 3 times 7. And then we have our plus 7 equals 28. And then what's the next thing we would do? Well, next we would multiply by 3, right? Because parentheses are done. Exponents are next. We don't have any exponents. Multiplication or division, I see multiplication, so we have to do the division portion, right? So first we had to do this part. Then we have to do the multiplication here, right? 3 times 7 is 21 plus 7 equals 28. And the last thing we would have to do is the plus 7. What is 21 plus 7? That is 28. And 28 equals 28. That's perfect. All right. Moving on. So we did check it and it does work. Moving on. Let's do number 9. We're not going to bother with the check this time. We're just going to make sure that we have the operations correct. So the first operation that we would perform to t, we're using the variable t now. The first operation to t, well, let's see, up right next to it is a 2, which means we're multiplying by 2. So the first operation to t is going to be times 2. The last operation to t, it looks like we would do t and we times 2, then add 8, then divide by 3. Because the 3, right, there's that division bar, is underneath the entire top part. So that's what would happen last. So the last operation to t is divide by 3. And if we were solving, well, we'd start by multiplying both sides by 3. So times 3 happens first, then we would subtract 8, and then finally we would divide by 2. So once again, right, we have opposite operations, right? Operations that sort of undo each other, but with the same numbers ending up diagonal to each other, right? So our times 2 and our divided by 2 and our divide by 3 and times 3, right? They're the same numbers, but one's multiplication, one's division. All right, moving on. We are done with 9 and 10. So solve each equation and check your solution. All right, so we're solving and checking. Solve and check. All right, no shortcuts here. Solve and check. Let's do this first one in green. All right, solve and check. So 4b minus 2. The first thing we're going to do is the parentheses. Wait, in the parentheses? No, that was if we had a number, right? That's what we would do. That's the first thing that happens to be. But in order to solve, we have to go in reverse order. So the first thing we're going to do is multiply both sides by 5. So if we multiply both sides by 5 times 5 and times 5, we should end up with 4b minus 2 equals 40. All right, if we then divide both sides by 4, divide by 4, divide by 4, right? We should have b minus 2 equals, what is 40 divided by 4? It is 10. And then finally, we're going to add 2 to both sides. Add 2, we get b equals 12. All right, so that is our solution. And our check, let's just make sure. If we plug in a, oop, we're not supposed to be writing right now. There we go. If we do plug in a 12, does this work? So let's rewrite it 4, and then we're just going to replace the b with a 12. 12 minus 2 divided by 5 equals 8. All right, that's what we said the answer was going to be. So if this statement is true, if the left side does equal the right side, then this is the correct solution. So we're going to check. First thing we're going to do, they're checking the fire alarms again. All right. Hopefully we don't get interrupted again. That would be unfortunate, but it happens. All right, so the first thing is in the parentheses 12 minus 2, right? 12 minus 2 becomes 10, so this should be 4 times 10 divided by 5 equals 8. All right, next thing we do is the 4 times 10, so it becomes 40 divided by 5 equals 8. And finally, if we do 40 divided by 5, we do end up with 8 equals 8. All right, so we ended up with 8 equals 8, or something equals itself. So I don't know if they're as disruptive on the video as they are in person, but those alarms are, I mean, they work. They work. It's not that bad, I suppose, but all right, let's move on to 15. Here we go. All right, let's do this a little bit more efficiently, hopefully a little space efficient, because we have to do 16 right below it as well. So, all right. First things first, let's solve for x. So we have to subtract 2 first. So if we subtract 2 from both sides, we're going to get 4x minus 5 equals 16. All right. Then we're going to divide both sides by 4. Dividing by 4, because we don't have a lot of space. If we divide both sides by 4, we should get x minus 5 on one side, and then equals, what's 16 divided by 4? Well, 16 divided by 4 is just 4. And the last thing we have to do is add 5 to both sides, plus 5, plus 5, and we should get x by itself equals 9. All right, our check is going to be, let's plug in this x equals 9. All right, so we're going to rewrite our whole equation. 4. Now, instead of writing x, we're going to write 9. 9 minus 5, in parentheses, plus 2 equals 18. All right, if this works, then we're going to be all set. All right, so let's go and make sure that it does. First thing we do is parentheses. That's 9 minus 5. So 9 minus 5 is 4, so we should have 4 times 4 left in the parentheses, plus 2 equals 18. Next thing we do, right, so that was the parentheses done. Next thing we do is the multiplication here. What's 4 times 4? If you said 16, you got it. 16 plus 2 equals 18. Now, some of you might realize, yes, this is true, but we are going to be thorough and just do the 16 plus 2 and have 18 equals 18, and that is true, so that checks. All right, on to the last one, number 16 for the set portion, right? The S portion of the RSG. So let's solve it first. We have negative 5x minus 12 equals 48. All right, the first thing we are going to do to solve is add 12 to both sides. Add 12, add 12. What do we have now? Minus 5x equals, what's 48 plus 12? It's 60. And then we have minus 5x equals 60. Well, we have to get rid of the negative 5, which is multiplication. That's multiplication happening. So we divide by negative 5. You can divide by negatives. It's totally fine. So divide by negative 5 on both sides. Oh, divide by negative 5. I do not love how that copied over. Let's try that again. Divide by negative 5. There we go. And now we have x equals, what's 60 divided by negative 5? It is negative 12. All right, x equals negative 12. That was our proposed solution, and let's check to make sure that's correct. So we're going to rewrite our original equation, but in purple. All right, we have negative 5 times, and I'm going to put parentheses here wherever we're putting the x. It's going to be negative 12 minus 12 equals 48. All right, let's make sure this works. First thing we're going to do is the parentheses, right? So this is definitely negative 12, so parentheses are taken care of. Then we're doing multiplication, right? Because if we have a number next to parentheses, we're multiplying. So that comes before the subtraction. So let's do negative 5 times negative 12. Well, two negatives multiplied together is a positive. 5 times 12 is 60, so we're going to have positive 60, right? When we do this portion, we're going to have positive 60 minus 12 equals 48. And then the last step is, what is 60 minus 12? It is 48. So 48 equals 48, and that checks. All right, so x does equal negative 12 because that checked. It worked. All right. For the go portion, it looks like we have 2 to do on this page, and maybe we have more after this, but we will go see. Indicate whether the given value is a solution to the corresponding equation. Show your work. Excellent. All right, so now we don't have to solve for x. We really just have to plug in this and see if it ends up being some number equals itself, right? So we're just doing the check portion. It's saying, here's the solution, check to see if it's the correct solution. So we're just going to check. So let's plug in, we'll just do this first one in green, second one in purple. So we'll do this one in green. So we're just going to plug in 4/3 for x. So we have 3/4 times 4/3 plus 1/2 equals 3/2. All right, so let's see what we can do here. Well, 3/4 times 4/3. Well, we know when we multiply, this is going to become 12 on the top and 12 on the bottom. So when we do this portion, we get 12 divided by 12. Then we're left with plus 1/2 equals 3/2. All right, let's change this up a little bit. Let's rewrite this a little bit, because currently what we have here is 12ths and halves added together. So I want to rewrite this 12 out of 12, right? This is the same, right? Let's make a little note here, right? 12 out of 12 is the same as 2 out of 2, right? We can do that. It's just saying 1 is equal to 1 is equal to 1, right? They're all equal to just 1. So let's make it 2 out of 2. So then we have 2 divided by 2 plus 1 divided by 2, or 2/2 plus 1/2 equals 3/2. Is this correct? Yes, actually. We're going to have 3/2, because if you have 2/2 and you add 1 more, that is 3. So 3/2 equals 3/2. And that checks, so we go over, and yes, 4/3 is a solution to this equation. So that's perfect. And let's go down and do 19. All right, y equals 2. This should be pretty easy to plug in. We'll do this one in purple. All right, so, it's 2.5y. Ooh, this is going to be interesting. All right, so let's see. First off, we're going to rewrite our equation. 2.5 times 2, right? We're just going to plug in a 2 in parentheses for y, minus 10 equals negative 0.5. And it seems like we're doing this one in decimals instead of fractions, so that's fine. First thing we do is this multiplication here, right? 2.5 times 2 is going to be 5. So we have 5 minus 10 equals negative 0. Oh, that didn't write well. Here we go. Try that one again. Negative 0.5. Let's evaluate this left side here, right? 5 minus 10. What is 5 minus 10? Well, if we have 5 things and we take away 10, we should have negative 5 things left. So we have negative 5 equals negative 0.5. Now, if we weren't paying close attention, we might think, oh, negative 5 on this side, negative 5 on the other side, but this is negative 0.5, which is negative 1/2. So this is not correct, right? It does not equal. So what we'll actually do is we will put a big slash through the equal sign, and that means that it is not equal. So negative 5 is not equal to negative 0.05, which means answer is no. No, that is not a solution, right? 2 is not a solution to that equation. All right. Let's go look at this last page. Do we have anything to do on it? We do not. So that wraps up homework help for Unit 4, Lesson 1.